So our discussion for today will be all about binary operations. So what are binary operations? So this is the definition for the binary operation. Let S be a non-empty set. So when you say non-empty set, so it is not empty, of course. And star said to be a binary operation in S if A star B is defined for all A and B is an element of S. So A and B should be part of S. So in other words, a star is a rule for any element in the set S. Excuse me. So the following are binary operations on Z. So what do we mean by Z? So this is a set of integers. So the arithmetic operations, addition, subtraction, multiplication, and division. But in the module, there was an additional operation which is modulo, but we will not be discussing that part since you are not math majors. So the we define an operation O plus on Z or on integers, set of integers by A, O plus B. So if you are going to look at it, there's a circle and a plus sign inside. So we read this as O plus B equals AB plus A plus B for all. So the symbol is for all or for every. A and B is an element of Z. So an element of these are integers. So for example, we have 2O plus 3. So using the operation RA is 2. So RA is 2. Okay, sorry, that should be so RA, oops, okay. RA is 2 and our B is 3. So using the formula, we have A times B plus A plus B. So we just simply substitute it using the given definition. So 2 times 3 is 6, is plus 2 is 8, plus 3 is 11. So 2O plus 3 is 11. So let's try the second one. So negative 2 times 3 plus 2, so plus negative 2, so that's minus 2 plus 3. So that's negative 6, minus 2 is negative 8, plus 3 is negative 5. Negative 5, sorry. My throat is itchy. So, well, for example 3, we have 3 times 4. Good thing our online engagement is cancelled, or else I'll be having hard time explaining. Plus 3 plus 4. So that gives us 3 times 4 is 12, plus 3 is 15, plus 5 is 19. So that's equals to 19, the 3O plus 4. Sorry. So for the next operation, define an operation O minus on Z by A O minus B equals AB plus A minus B for every A and B is an element of Z. So if you're going to compare it with the addition, this is the only difference. Okay, so using exactly the same example, so we have 2 times 3 is 6, plus 2 is 8, minus 3 is 5. So let's have example 2. So that's negative 2 times 3 plus No, minus 2 already. Minus 2 plus, no, minus 3. So negative 6 minus 2 is negative 8, minus 3 is negative 11. So next is 3o minus 4. So 3 times 4 plus 3 minus 4 equals, so 3 times 4 is 12. 12 plus 3 is 15, minus 1 is, minus 4 is 11. So 3o minus 4 is 11. So the next one is define an operation O times on Z by AO times B equals A plus B quantity times A plus B quantity for all A and B is an element of Z. So these are very, very important as part of the definition. So from the example, we just replace it by the O plus operation. So that becomes 2 plus 3 quantity 2 plus 3. So this is 5 and the other one is 5. So 5 times 5 is 25. For the second example, that is negative 2 plus 3. And then repeating it times negative 2 plus 3. So that's 1 times 1 is just basically 1. And for the third example, we have 3 plus 4 times 3 plus 4. So that's 7 times 7. That is equal to so 349. Next, define an operation O slash on Z by A O slash B equals A plus B times quantity 8 minus B. So the only difference between the O times and the O slash is this part. So in the O times this is plus, but in the O slash this is minus. So this is 5 times negative 1. So that's negative 5. So using the second example, we have negative 2 plus 3 times negative 2 minus 3. So that gives us 1 times negative 5 is still equal to negative 5. So correct now? Am I right? Yeah, because this is positive 1 and this is negative 5. Okay, for the next example, we have 3 plus 4 negative, no, that is 3 minus 4. Excuse me, I'm sorry. So this is 7 times negative 1 is negative 7. mm, -7. Next, define an operation min on z by a minimum b. So min is minimum equals. So for this case, we just simply get the minimum value, the smaller value. For all a and b is an element of z. So here, the smaller value is 2. In number 2, the smaller value is -2. And for number 3, the smaller value is 3. So look at this symbol, minimum, that's the ceiling. So, no. In layman's term, we call it, what's the floor, ma'am? So, minimum value. Well, the other one is our ceiling. What's the ceiling? Kanang, when we do hangyo, what's the maximum, or when we sell something, what's the maximum amount that you can sell this one? So in this case, that's max. So the symbol, look at the symbol, it's on top. So we just simply get the higher value. So for the number 1 is 3, number 2 is 3, and number 3 is 4. Okay, the last one is we define an operation defect on Z by A star sub 3 of B equals AB minus 3. So you just simply subtract. So you just have A and B minus 3. So here we have -2 plus 3 minus 3. So -2. And then we have 3 plus 4 minus 3. So that gives us 4. Okay, so that would end our discussion about binary operations.